Geometric sequences and series in Algebra 2. A geometric sequence is the second type in our sequences and series. This occurs when you are multiplying by the same number. And we can say it's multiplying and dividing, but you have to remember anytime you are actually dividing by a number for these, you are really multiplying by a fraction. So my example is if I go from 16 to 8 to 4 to 2, we can say that we are dividing by 2 or that we are multiplying by 1/2. So that is the relationship between fractions and division. So again, reading the directions for the first part, decide whether the sequence is arithmetic, and that's when we add or subtract, geometric, it's when we multiply, or neither. If it is arithmetic, we need to find D, which was our difference. And if it's geometric, we are finding R, which stands for ratio. So number 1, I notice I'm going from a positive number, negative number, positive number, negative number. I know that's not arithmetic. Anytime my signs change, it's either neither or geometric. So first, I'm going to check if it's geometric. I'm going from 81 to a smaller number. So that means I'm probably multiplying by a fraction. And the easiest way to find that out is to go to your calculator. You are going to take the second number. In this case, negative 27. And we're going to divide that by our first number, which is 81. Hit enter, math, enter, enter, so negative 1/3. And you can always double check it by starting with the first one. So 81 times negative 1/3 should give me negative 27. It does. Now if I multiply that again by a negative 1/3, I get positive 9, so on and so forth. So in this case, we would say it is geometric, and that R equals negative 1/3. Now with number 2, we look. These are all positive numbers, so arithmetic is the easiest one to check. 1 plus 1 gives me 2. Does 2 plus 1 give me 6? No. So then I check 1 times 2 gives me 2. Does 2 times 2 give me 6? No. So this one is neither. Just like with arithmetic, we are going to have a formula. This formula is given to you on your formula sheet, but this is how we find our nth term. Alright, so the directions for number 1, write the first 4 terms of the geometric sequence. So that says nothing about a formula, so I don't have to write it. I know my first term is 2. So if a sub 1 equals 2, and I know my ratio is 3, that means in order to find that second term, I'm going to take my first one and then multiply it by my ratio, so that'll give me 6. So my first one was 2, my second one was 6. So then to find my third one, I would go 6 times 3, which is 18. And then my fourth one is 18 times 3, which is 54. Problem number 4 gives me the formula, so in order to find the first 4 terms, I just have to plug in a number. So a sub 1 equals 2 to the 1 minus 1 power, and you can put this in your calculator, which should give you 1. So then a sub 2, we're plugging in the 2 for n. So 2 times 2 2 to the minus 1, and that equals the number 2. Then the third one, we plug 3 in for n, so 2 to the 3 minus 1, it's going to give us 4. And then a sub 4 is 2 to the 4 minus 1, which gives us 8. So there are my first 4 terms of each sequence. And remember, a sequence is just a list of numbers. Now let's move to the bottom. So the directions for 5 and 6 say, write a formula for the nth term. Now the nth term formula is the green highlighted one right here. You all have it on your paper, so you don't need to rewrite it down. I am going to write it down so we have it in view. So a sub n equals a sub 1 times r to the n minus 1. So again, the two things that you always need are a sub 1 and r. So looking at number 5, do I have a sub 1 and r? Yes. So I can just plug it in. A sub n equals 4 parentheses negative 3 to the n minus 1. That's my formula. I don't need to simplify anything with geometric, which is nice. And the second part says I need to find a sub 7. So a sub 7 equals 4 times negative 3 to the 7 minus 1. Then from here, we can go to our calculator. 4 parentheses negative 3 to the 7 minus 1. 2,916. So a sub 7 equals 2,916. Number 6 is very similar. Two things you need are a sub 1 and r. So a sub 1 is 5, because that is my first number. Then r is what I'm multiplying by. So 5 times what gives me 10? 5 times 2. So r equals 2. Which means my formula is a sub n equals 5 times 2 to the n minus 1. And there's my formula. Then to find a sub 7, we go a sub 7 equals 5 times 2 to the 7 minus 1. And we go to our calculator. So 5 times 2 to the 7 minus 1. And we get 320. So a sub 7 equals 320. So that is geometric sequences. Remember, a sequence is my list of numbers. Now if you flip the page, we're going to talk about a series. Now series is when we are adding all the numbers in our sequence. And your formula will look like this on the SOL formula sheet. But remember, anytime it's asking for a series, we're going to use that letter E. And your starting point is on the bottom. Your ending point is on the top. And the formula is next to it. So for this example, it's very, very similar to the arithmetic ones that we did. First part is find the formula for the nth term of the geometric series, so I know I am multiplying. Then answer part B. So first I need to find my nth formula, which is a sub n equals a sub 1 times r to the n minus 1. So a sub 1 equals the number 1, r equals 9, because that's what I'm multiplying by each time. So a sub n equals 1 times 9 to the n minus 1. This one is a little interesting because you will mostly see it written as a sub n equals 9 to the n minus 1. Why? Because it's a number 1 in the very front. And if you don't see a number, it's implied that it is the number 1. So we did part A, have our formula. Now we have to do part B. Write the formula to find the sum, right, so I need the e, of the first 8 terms. Then find the actual sum. So e, we have x equals 1. We're going to 8. Then we're going to have 1 parentheses 9 to the x minus 1. Now this one's a little tricky in the calculator. To find our e, remember we go alpha, window, 2. Type in x equals 1. 8 is on the top. Now, notice the calculator already gives you parentheses. Those parentheses in the calculator need to have the entire rule. So inside I'm going to type 1, then another set of parentheses for the 9 raised to the x minus 1. So there should be nothing on the outside of your parentheses. We hit enter, and we get 5,380,840. So there's my sum, and this is my formula. You do need both in part B. So that's an overview of the series. We've done plenty of those with the arithmetic. It's the same situation with the geometric. We're just using a different formula. Now, one more thing with geometric, and it is a special case. This will 99% of the time show up on your SOL, and it's called an infinite geometric series, which means you are again dealing with our infinity sign. This is the one time that the e is not allowed. So anytime we see the infinity, that means no e. You have to use the formula that's on your formula sheet, which looks like this. And it's read, the sum of the infinite series equals a sub 1 over 1 minus r, only when the absolute value of r is less than 1. So that's the first thing you need to realize, is the absolute value of r has to be less than 1. So let's look at number 3. Have e, so I know it's a sum, but I notice there's an infinity on the top. So this infinity means I need to use this formula. But how do I get a sub 1 and r? Well, remember, our e's have our starting point on the bottom. They have our ending point on the top, and they have our formula next to them. And our formula is a sub n equals a sub 1 times r to the n minus 1. So a sub 1 is always in front of the parentheses. So for number 3, my a sub 1 equals 3. R is always inside the parentheses. So my r is 0.07. Is the absolute value of 0.07 smaller than 1? Yes, so I can use this formula. So if I plug everything in, I have the sum of the infinite series is equal to 3 over 1 minus 0.07. Now we just look to combine our like terms in the bottom. Or if you want, you can put the whole thing in your calculator, which is what I usually do. It is hard with the parentheses. If you were doing it the old school way, remember you have to go parentheses on the top, divided by parentheses on the bottom. Or you can do alpha, y equals, enter. And it gives you a fraction bar with a box on the top to type in and a box on the bottom. So if we do that, we would go alpha, y equals, enter, and I could just type in 3, and then on the bottom I can type in 1 minus 0.07, hit enter, and it gives me a decimal. So I do want to change that to a fraction, which is math, enter, enter, and I get 100 over 31. So the sum of my infinite series is equal to 100 over 31. Now let's try number 4. So again, my a sub 1 is the number in front, which is 4. My r is in the parentheses, which is 1/4. The absolute value of 1/4 is smaller than 1, so then I can plug into my formula. So the sum of the infinite series equals 4 over 1 minus 1/4. And again, we can just plug into our calculator. Alpha, y equals, enter. 4 is on the top, and then we go 1 minus, parentheses, 1 over 4, enter. Another decimal, so we go math, enter, enter, and we get 16 over 3. So my sum of the infinite series is 16 over 3. So this part is really important to remember, that anytime there's an infinity, you have to use a formula. You can't use the e.